Hey, what's going on, guys? My name is Zero Davila. Welcome back to Save Our System IT. Today I'll continue part number 18 of our Busybox series. Run parts runs a number of scripts or programs found in a single directory. File names should consist entirely of upper and lowercase letters, digits, underscores, and hyphens. Subdirectories of the directory and files with other names will be silently ignored. Scripts must follow the hashtag !bin/interpreter name convention in order to be executed. They will not automatically be executed by /bin/sh. The files found will be run in the lexical sort order of the file names. Sed is short for stream editor, and it allows you to filter and transform text. Sed is a stream editor. A stream editor is used to perform basic text transformation on an input stream, a file or input from a pipeline. While in some ways it is similar to an editor which permits scripted edits, such as add, sed works by making only one pass over the inputs, and is consequently more efficient. But it is sed's ability to filter text in a pipeline which particularly distinguishes it from other types of editors. On Unix-like operating systems, sec is a utility for generating a sequence of numbers. In its most basic use case, secn prints out all the integers from 1 to n in a sequence. This was convenient as the Unix shell at the time, the Bourne Shell, had no primitives for iterating over numbers, and its for command could only iterate over a list of words. Sec was therefore used to generate such a list, as in this example. So to remove file 1 through file 17, we would have a script like this. For n in sec17, do rm file n. Sec had additional options for controlling the start and not just the end of the numeric sequence, its increment, a floating point number, and the formatting of the number. GNU-sec changed the name and meaning of the format option from P to F and added an option to control the separator between the numbers, S, which defaults to a new line. The setkeycodes command reads arguments two at a time, each pair of arguments consisting of a scan code given in hexadecimal and a key code given in decimal. For each such a pair, it tells the kernel keyboard driver to map the specified scan code to the specified key code. This command is useful only for people with slightly unusual keyboards that have a few keys which produce scan codes that the kernel does not recognize. The usual PC keyboard produces a series of scan codes for each key press and key release. Scan codes are shown by the show_key-s command. The kernel parses this stream of scan codes and converts it into a stream of key codes, key press release events. Key codes are shown by the show_key command. Apart from a few scan codes with special meaning, and apart from the sequence produced by the pause key, and apart from the shift state related scan codes, and apart from the key up-down bit, the stream of scan codes consists of unescaped scan codes, XX, or 7 bits, and escaped scan codes E0XX, or 8 plus 7 bits. It's hardwired in the current kernel that in the range 1 to 88, or 0x01 and 0x58 key code equals the scan code. For the remaining scan codes 0x59, 0x7f, or scan code pairs 0xe0, 0x00, 0x0, 0x7f, a corresponding key code can be assigned in the range of 1 to 127. For example, if you have a macro key that produces E06f according to show_key1, the command setkeycodes E06f112 will assign the key code 112 to it, and then load keys can be used to define the function of this key. If you need to run any program or command and then leave the shell session or SSH session, but be sure to leave the command running behind you, then you can use setsid. Setsid creates a new session ID for the command you run using it, so it does not depend on your shell session. Therefore, if that shell session is closed, the other command will stay running. For example, you can run a command that writes its output to a file. This way, the output will be in the file and you can always check that file using tail. SH is the Bourne Shell. There are several shells, of which Bourne is the old standard, installed on all Unix systems and generally the one you can guarantee will exist. The shell is the command interpreter that takes your input, provides output back to the screen, to the correct files and so on, and provides all the basic built-in commands you need to manage jobs, kill, test expressions and so on. Your command above is saying to run that shell script using the Bourne Shell. Different shells use different syntax, so using the correct shell is a requirement. The first line of the shell should also define which to use. Hashtag !bin/sh says to use /bin/sh, the Bourne Shell. The sha1sum command computes the sha1 message digest of a file. This allows it to be compared to a published message digest to check whether the file is unmodified from the original. As such, the sha1sum command can be used to attempt to verify the integrity of a file. SHA1 produces a 160-bit or 20-byte hash value known as a message digest. And although SHA1 is no longer considered to be secure against well-funded opponents, it's still widely used to verify files. Now, how to get a SHA1 of a file? To get the SHA1 of a file, pass the path of a file to the sha1sum command. The SHA1 will be printed to the standard output, printing first the sha1 checksum, then the name of the file. With all issues relating to security, things move fast. The MD5 hashing algorithm is now widely considered to be insecure. The SHA1 hashing algorithm is also expected to be insecure. As such, it is expected that new algorithms will eventually emerge and be widely used. Already there are many checksum commands distributed with Linux, and it is expected that this will evolve. sha1sum, sha224sum, sha256sum, sha384sum, sha512sum. For each of these hashing algorithms, the command options and behavior is the same, so when a hash algorithm changes, it is a drop-in replacement. The sleep command is used to delay for a specified amount of time. The sleep command pauses for an amount of time defined by a number. Suffix may be S for seconds, which is the default, M for minutes, H for hours, or D for days. Some implementations require that number for an integer, but in modern Linux implementations allow number to also be a floating point value. If more than one number is specified, sleep delays for the sum of their values. And that's about it for today. Don't forget to like, share, and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.